Once again, I've already written down our givens and requireds, but I'll read the question for you anyway. Combustion of a sample of an unknown compound gives only two products, 6.29 grams of carbon dioxide and 3.86 grams of water. The unknown therefore contains only carbon and hydrogen. The molar mass of the compound is found to be 30 grams per mole. Determine the molecular formula. So molecular formulas are required. They gave us the molar mass of the compound. They gave us the mass of carbon dioxide produced when it burned, the mass of water produced when it burned. And one more thing that's key here is there's only carbon and hydrogen in the compound. You could combust it and have oxygen be there as well, and you wouldn't be able to tell whether this oxygen came from the compound or from the oxygen in the combustion. So sometimes you get these types of ones where you have to subtract off the oxygen from the original mass of whatever you had. So we'll have to see if we get any of those. Okay, we're going to do this very similarly to the last time. There's a couple ways to do it. The way I originally see doing this is this oxygen comes from the air. It comes from the combustion of our compound plus O2 makes CO2 and H2O, just like any combustion reaction we see. So the O's come from here and aren't part of our compound. It's the C's and the H's that are part of our compound. So what I want to do is I want to get the C and the H by itself. Now there's a few ways to do this. The way that I want to do this is find the percent composition of C in CO2, right? Just find that out and multiply it by the mass of CO2, which would equal the mass of C that's in our compound. That's what I want to do. That's one way to do it. The other way is to get that mass, or get the number of moles, because that's what we want to do. You get the mass of carbon, then you find the moles of carbon, and then you do lowest terms, right? And that's your empirical, and then you compare your empirical to molar mass, right? Your empirical mass to your molar mass, and that's what our goal is. So that's one way. That way would work. If you're comfortable working with percentages, you can go ahead and do that. I've told a few of you to do that, and it works. It's fine. Looking at a few people's answers, some online and some in the book, I like the other way better. It's a little streamlined. The goal here is to find out how many moles of carbon came from the compound. So I can get my mole ratio of carbon to hydrogen. Well, alright, let's find that, but let's do it a little differently. Let's find moles of CO2, which is the mass of CO2 divided by the molar mass of CO2. So that's 6.29 divided by, now I gotta find this, my calculator, 15.994 times 2 plus 12.0107. I've got 44.0095, and that equals 6.29 divided by 44.0095 equals, I got 0.1429236 moles of carbon dioxide. But the moles of carbon are equal to the moles of carbon dioxide multiplied by, there's 1 mole of carbon in every 1 mole of carbon dioxide, because every 1 mole of this has 1 mole of that, which means moles of carbon dioxide cancel and I get moles of carbon, so it's 0.1429236 moles, because they're the same. So that works out well. The moles of water I have are equal to the mass of water divided by the molar mass of water, and that equals 3.86 divided by 18.01528, I think, or 529. 28. They're 1.0079 15.4 times 2 plus 15.9994, 528, yep, equals 3.86 divided by 18.01528 equals 0.21426 moles of water. But I don't want moles of water because it's got oxygen there that's not in my original compound. I want moles of hydrogen. So moles of hydrogen equal the moles of water times, and there are 2 moles of hydrogen for every 1 mole of water. So that effectively is 0.2142626 times 2 divided by 1, which equals times 2, 0.42852512. So my ratio of carbon to hydrogen in this case is 0.14292369 to 0.42852512. Divide both by the lowest. I'm assuming it's about a 1:4 ratio. I know this is 1. What is that? Divided by 0.14292369. Yep, 3. 2.998 at that point when I round. So therefore, it's 1 to 3. Okay, I'm running out of room. That's my empirical. So now, in order to find that magical x value, the ratio, it's the molar mass of the compound divided by the molar mass of the empirical. Well, I have the compound is 30 grams per mole. I need to find the molar mass of CH3. So that is going to be 1.00794 times 3 plus 12.0107 plus 15. We already kind of have our answer. 15.03452, which is going to be about, I don't even need to do this, it's about 2, right? I'll just erase that, sorry. It's going to be approximately equal to 2, which means it's C2. H6 is our answer. So when we get masses, there's a couple ways we can do it, but we ultimately, our goal is to always get to the moles of each individual piece from the beginning. So when in doubt, find the mole. So you find moles of each element. You do this step, you divide by the lowest number, you find the simplest whole numbers, and then if possible you compare the molecular mass of the compound by the molecular mass of the empirical, which will tell you what to multiply it by.